Ever wonder how ChatGPT, Google Translate, or image generators actually work under the hood? They all rely on something called a transformer. It sounds complicated, but the core idea is surprisingly intuitive. Let's break it down step by step. No PhD required. A transformer is a type of neural network, which is just a fancy way of saying a computer program that learns from examples. It was invented in 2017 by researchers at Google, and it completely changed the game. Before transformers, AI had to read text one word at a time, like reading through a keyhole. Transformers look at everything at once, like seeing the whole page. Before transformers, we used something called recurrent neural networks, or RNNs. Think of an RNN like reading a book by looking at one word, then closing your eyes, then looking at the next word. By the time you reach the end of a sentence, you've kind of forgotten how it started. Transformers fixed this by looking at every word simultaneously, like having the whole sentence laid out on a table in front of you. The first thing a transformer does is chop your sentence into smaller pieces called tokens. These are usually words or parts of words. Then, each token gets turned into a list of numbers, kind of like giving each word a unique fingerprint. The model also adds position information, so it knows that the first word came before the second word. Without this, it would be like dumping all the words in a bag with no order. Here's where the magic happens. Self-attention is the transformer superpower. Every word in the sentence looks at every other word and asks, how relevant are you to me? Take the word bank. In riverbank, it should pay attention to river. In bank account, it should focus on account. The model learns to assign attention scores that capture these relationships automatically. Let's put some numbers on this. Each word gets 3 vectors: a query, a key, and a value. Think of it like a search engine. The query is your question, the keys are what's available, and the values are the actual content you retrieve. Modern transformers run dozens of these attention calculations in parallel, called attention heads. Each head learns to focus on different things, like grammar, meaning, or tone. The biggest models have over 1 trillion learned parameters. Transformers come in 2 main flavors. Encoders are great at understanding text. They read your input and create a rich representation of what it means. BERT is a famous encoder model used in Google Search. Decoders are great at generating text. They predict the next word, then the next, building up sentences one token at a time. GPT is the most famous decoder. The original transformer paper actually used both together for translation. Training a transformer is conceptually simple. You give it a massive amount of text, hide a word, and ask it to guess what comes next. When it guesses wrong, you adjust its internal settings slightly so it does better next time. Repeat this billions of times across terabytes of text, and the model develops an incredibly nuanced understanding of language. It's like the world's most intense fill-in-the-blank exercise. Transformers didn't just improve AI, they fundamentally changed what's possible. GPT-3 showed that a big enough transformer could write essays, code, and poetry. A single model can now handle over 100 languages. Today, transformers power everything from medical diagnosis to legal research to customer service chatbots. They're not just an academic breakthrough. They're the engine behind the AI revolution you're experiencing right now. So here's the bottom line. Transformers work because they let AI look at everything at once instead of one piece at a time. The self-attention mechanism figures out which parts of the input matter most, and the model learns from billions of examples. That's really it. One elegant idea, scaled up massively, and it gave us the AI tools we use every single day. Not bad for a paper published in 2017.